Test the hypothesis using the classical approach and then the p-value approach. Be sure to verify the requirements of the test. So let's start off by verifying our requirements of the test. So we want to check that n times p naught times 1 minus p naught is greater than or equal to 10. So 125 times 0.2 times the quantity 1 minus 0.2 gives us 125, oops, 0.2 times 1 minus 0.2 gives us 20, which is greater than or equal to 10, so we're good. And then we're going to assume that we have a simple random sample. And that our sampled values are independent. Okay. So now we want to do this using the classical approach. So we can still use StatCrunch for this. That'll give us our test statistic, which we need for the classical approach. But we also need our critical value. So to determine the critical value, we're going to look at two things here. We're going to look at our alpha and the symbol in our alternative hypothesis. So the symbol in the alternative hypothesis tells us that we are working with a right-tailed test. So anytime that is greater than, that means that it's right-tailed. Right? So this information is going to tell us how to find the critical value. So our critical value, okay, just type one here. We can use that table that I provided you guys. Since we have a right-tailed test, and the critical value here, alpha is 0.05. Let me pull this up. Right, so alpha is 0.05, and just right-tailed, we would just find that value in here. Right, so it's 0.05 and right-tailed. So we're right here, so 1.645. So our critical value is 1.645, so we can get that from the table. And now we need to find our test statistic. So we can use StatCrunch to do that. So we're going to go in, stat, proportion stats, one sample with summary. Type in our number of successes, which is 40. Our observations is 125. And hypothesis test, this is 0.2 for the alternative, and the null and the alternative, right? And this is greater than. And I'm going to hit compute here. So we get, this is, our test statistic is 3.35, so we're going to round to 2 decimal places here. So our test statistic is approximately 3.35. So we're going to compare these. So we're going to draw this out. I think it's the easiest way to do this. So if I have this here, right, so we have our normal distribution. We know that we can use normal because we verified those three conditions. Then our critical value is just a rough estimate, 1.645, and since it's right-tailed, we want the region over here. Okay. And then where does our test statistic fall? Where does 3.35 fall? 3.35 falls somewhere over here. Right? So it falls in the critical region. So when the test statistic falls in the critical region, we reject. So we know we reject the null since our test statistic is in the critical region. So the black region that I've shaded there is the critical region. Right? And now that we have a picture drawn out, we can compare. So our test statistic is greater than, less than the critical value. Trying to memorize all the conditions, you can just look at your picture and see, right? So our test statistic is greater than the critical value. So we look at our conditions, we know that we reject. So we can eliminate A and C. So we reject the null hypothesis because the test statistic we just identified is greater than the critical value. So we know doing the p-value approach, we should also get that we reject the null hypothesis. Right? So we know that our p-value should be less, right, than 0.05. All right, so let's extend this out. So we're going to use the p-value approach. We've already done the hard work. We did it in StatCrunch. So our p-value is 0.0004. Our p-value is 0.0004. Alright, so we're going to compare that to alpha. So our p-value and alpha, let's compare. So our p-value and alpha, 0.05. Our p-value is less than alpha, so we reject the null hypothesis, and our p-value is less than alpha, right? So do not reject, we never reject, and the p-value is less than alpha, right? So what actually is the p-value here? So if we look at this, and think about it, right? The p-value 3.35 is a probability, and it's that probability associated with that test statistic. So it's the probability of z being greater than 3.35. So let's verify this and look at this on StatCrunch. So if we go to Stat and then Calculators, Normal, we want the probability that z is greater than 3.35, and we hit compute, we're going to get 0.0004. So that's actually what that probability is. And just to pull this back up, I didn't do that on this one, I don't think. Edit, put the p-value plot in here, hit compute, and go over here. You can see that it's got the z-stat and then that plotted in on here, right? So that's everything over here, that test statistic there. And so that's how the two methods are corresponding, right? So you want, right, value more extreme. So when we have, right, so that value is unusual, then anything bigger than that would be also unusual, right? So we're unlikely to get that sample proportion. Therefore, the result is statistically significant, and we would reject that null hypothesis. So that's what we're doing here.